According to this timeline, detailed structural design starts on the 7th, so that's 1 week from today. So that means that starting now, we're really going to start thinking about like making CAD models, even if we don't have the exact dimensions from aerodynamics right now. We're going to start having to think about like making CAD models and thinking about going to actually build all the parts, and assembling all the parts always takes much longer than we expect. The numbers in there are starting to be finalized. They will probably fluctuate for a while.
If you want to update a part, name it exactly the same and drop it in, or else you're not going to get that same association. Also, try to download a previous date and then work from that.
I want you to kind of really think about the materials, especially because that's kind of lead you down the path of what your end up. If you had a CNC router, you could put it in the CNC but not cut all the way through, just like cut the top half or top like quarter or something. This article also says you can use a Dremel, which I'm not sure what that would look like.
So do you cut these holes before or after you've laid up on it?
You would cut them after you've laid up on it.
Yeah, so what I would do is take some time this week, take a look at this video and start brainstorming on certain ideas, how we would manufacture it, that kind of stuff.
How we would make this practical for our use.
Yeah, and for our scale as well.
Yeah.
Because they're obviously on a much larger scale than we are, but this is still a useful idea that we could take a look at and take advantage of.
Some way like thumb screws even. You could easily do that and then have a hole in the bottom, put the servo wiring.
We can put a drill inside the box. You get the handheld, like the ones that look like.
Well, that's just added weight.
No, isn't that part of the plan though?
That don't matter about the box.
Is that not part of the plan to have like power tools inside the crate?
Oh, we want to minimize.
Yeah, we need that, or else we're gonna have to.
Wait, those?
That's
All the tools are.
Yeah.
Oh, that's crazy.
But it would still be the same amount of pieces if you had the spar be part of the wings rather than be part of the fuselage.
It seems like it'd be way easier to secure the spar on the bottom of the plane than inside of the plane.
We don't want things to move left and right. We don't want the spar to slide out or anything. So right now, 2 constraints, wings to the fuselage. That will prevent the spar moving left and right. That will prevent the wings moving left and right, okay? Concern is now, how do we constrain how much the spar goes into the wing? So like a stopper.
So the spars actually going into each other, aren't they?
The spar, yeah. So you have your spar and then we have our spar, and
The spar is completely hollow. Why does that need to be a consideration of inside of our spar rather than a consideration on the outside of the fuselage connecting your spar? So essentially,
it's free in the fuselage. We don't want to have more bolts than 2. 2 is like the minimum bolts we can do, right?
Why can't we do fast removing fasteners that connect this to the fuselage rather than putting something inside of the wing?
Yeah, how?
That's kind of what we've been talking about.
There's no fasteners that will actually work on
Start drilling through both the spars. And honestly, if we're gonna drill through a spar, it should be further away.
Because like if you want to connect this guy to the wing, so we're gonna give like a little bit gap here. How much? Like of course we're not gonna hold the whole wing with the rod.
Oh, they gave us some numbers. I forgot what they were. I want to say it was like a foot that they were thinking.
Only a foot?
Yeah. Well, the wing's not super large. It's only 3 feet long. So.
Okay.
The actual mold that I've made, it needs to be edited a little bit because what I did, this wing is supposed to be the skin dimension. I used it as the actual foam and spar edge. So there is a little bit like a 0.0415 inch thickness that goes beyond this. And it oversizes our wing a little bit. So I'm gonna edit that.
We're doing our 3-point bending. Did Colin check the lab?
I don't know. I haven't heard from him.
Wait, what happened?
Somebody cut this wrong. It's not the same size.
On the difference.
Oh, like, I mean, this one's not. This one's, I had to cut that at an angle.
Oh, got it.
I mean, this one's way farther off though. Look at that.
Yeah, we could always sand this down.
Yeah.
Here we're working on our makeshift 3-point bend test. You can see that we have a bucket loaded down below that we're loading up with textbooks that we've measured the mass of, so we can calculate the amount of stress that's being applied to our carbon fiber samples.
So we are about to glue some foam together because we're going to be making a test fuselage mold in the autoclave. So this is a high temp glue. And this is high density foam that can go in high temperatures. So we're going to glue it together so we can use the router to make a mold. Wow, this smells really bad.
Ew, I can't do this.
What does it smell like? That is all the glue that we have.
Why do I feel like when we put them together, they'll just immediately...
Yeah.
I don't know where the tape is.
The wing contains a spar that goes through the center section. We're going to build it out of carbon fiber. It needs to be a box shape, but box shapes are hard to make out of carbon fiber, so we're making it out of 2 separate C shapes. Thing is, of course, we need to bond the carbon fiber in the shape we want it. So right now we're cutting out the pieces of carbon fiber to stack around this thing, which we will then vacuum bag and seal and then put together and test.
And then we're going to tape this down to make sure that it's snug so that it's not moving around when we're doing our layout. And then once we get all of our layers on, we'll put our tacky tape.
Can you tell me if it's straight?
Okay.
Perfect.
Yeah.
Okay.
What is this?
So this is resin. This is what we're going to use to get everything stuck together.
Alright, you have to stir it.
A few minutes. Just make sure you get all consistent. Scrape whatever hardener you have off the walls. Then you're just going to take This is a 90, right? Yeah, this is a 90.
That's 45.
Make sure you're going in a 45-degree angle.
That should be good.
We're gonna start with another 90 degree.
Yep, so another 90 degree for
Can we have another 90 degree?
Yeah, where's the end of this one?
Yeah,
Okay.
it's covered.
This one's got a pretty big bubble in it.
Okay.
You think that'll be fine?
Oh yeah, that's a big bubble, isn't it?
This is gonna be the test bar, right?
Yeah, these are just tests. Okay, hold it over there.
Try and not get any wrinkles in there either. You gotta get that airtight seal. So you're gonna take the very end, so right here. You're gonna stick it down just like that, and then you're gonna just go around the edge.
Gonna fold this over and create a seal, or just this pleat here.
Yeah, for the big thing.
I think it's already hard. Maybe not.
No, it's just sealed.
It's backwards. So we are changing the physics by adding.
Yeah.
And then the displacement.
Oh yeah, you needed zip ties to lock it down.
Okay, so basically what we did here is we did an envelope bag. So we had a long piece of bag and we folded over, sealed at the sides with tacky tape, and then sealed at the top. And then we attached a vacuum port up here, which is running through to the vacuum. As you can see, we got a lot of pressure on these parts that we're making. And you can see the resin is actually coming through the perforations on the perforated release film that we have.
The purple one might do something. Oh, I see it.
Yeah?
Yep.
Oh yeah.
The purple one.
Yeah, that's...
I think it's like the best it can be right now.
Yeah.
Yeah?
Failure at whatever that is. These linear fiber toes. When we had load on one place, it creates that defect, right?
Yeah.
You're bending those fibers, and so they're snapping in that location. And you just did it with your muscles, but
I didn't even, I was just like feeling it, it went snap.
wow.
I wonder if we had oriented it the other way. Would it make a difference?
We have a bunch of data that we had from APC and we have data from eCal, right? But now we want to make sure that that's real for our measurements. And that's why we're trying to actually test it out rather than just consult a book, essentially.
A wind tunnel testing photo, and there is a supervised wind tunnel test pen.
It's Aircraft Design, a Conceptual Approach, 6th edition, Daniel P. Raymer.
Okay.
That is the Bible that Daniel was using last year.
Bible. Okay.
Well, okay, he, like, 70% of what he cited was out there.
I can start bringing up some stuff with that.
Yeah, start with a basic equation, free variable, you're wanting weight out of it.
Basically the one from Anderson.
That's what I'm currently using. You're welcome to look around and try and find something else, but most of those equations seem to run more or less along what Anderson had, so...
There's a reason we use it for classes.
Well, yeah, but I don't know. Anderson, or I don't know. I'm having a hard time making the connection right now between the actual practical stuff people use for actual flying planes and all the theory behind it. It's feeling like there's a bit of a disconnect somewhere in here between how theory approaches things and how that.
So you said we want to pull weight out of it. What do you mean by that?
Basically, we have a fixed takeoff length.
Okay.
We got a bunch of geometry variables we can't tweak too much.
And so make sure that.
And then basically we want to maximize weight there.
Okay. So basically we're assuming we're going to take off in 60 feet.
Well, we need to take off in 60 feet.
But we're basically we're backing out, saying we're going to take off in 60 feet. What is that?
And then you're back solid pulling.
Okay. We can do that.
We found that slaughter flaps will theoretically increase by 1.3, which gets us to the limit, but we're not going to be using it for the entire wing, which obviously reduces the value that it gives us.
Yeah.
So we're finding other ways.
So you guys are working on high lift devices then? Okay, you're like modifying the existing airplane. Okay. Do you know what the end of your project looks like? Like where this terminates, like in come 20th, what are you going to have to deliver? Like, do you know?
20th? Well, we need to reduce the turning radius as much as possible.
Okay.
So
you're presenting solutions for that, essentially. Like what? Like slats might give us high lift, like, but is it going to be useful like when returning? Because it's probably going to give you so much drag that like you're falling out of the sky, right? You might make the turn effectively, but like dipping out. So define those use cases.
Slaughter flaps help, but how does that translate to our scale? Well, I think it might be harder to kind of find analysis on, but something to also consider is how it affects our scale.
That's a great point actually, because it might have drastic effects for like a 787, or it might have drastic effects for like a 37 max. But when it's an RC plane with 6 feet wingspan, you have to weigh the manufacturability versus actual performance increase.
The one with all the different tails?
Yeah.
Like this one? Okay. Put it on there?
Just put like screenshots. Okay, give it at 0 point. That's a massive amount of induced drag. Okay, so discussing here, where did that 0.067
Okay,
come
let
from?
me split up because I got that from an article at Home Built. I want to do slightly better than that.
And I don't know, you need to be careful with that CV value because two
Well,
years
that
ago
one
with the
was
Dragonfly was
horizontal
weird.
anyways.
Yeah,
So
he wanted us to
we're-
solve for weight. We're starting with all of our fixed parameters, the maximums, the takeoff distance, any of the other characteristics that are basically fixed that we can't change, and then seeing how the stuff we can change depends on those.
Could you give me a list of numbers then, since I've given you a plain body?
Yeah. Control surface sizes would be nice to have.
Okay, that's not going to be for another week and a half.
Okay. Drag values to evaluate fuselage designs.
CD0 does not seem to change much. Max is currently 0.3, but actual one from OpenVSP is like 0.2. That 0.3 is safety margin.
Initial goals, I think we said 8 pounds, right, for the plane? Is that 8 to 10?
8 to 10.
Okay.
The number is flexible.
Your wing mounting mechanism, why don't you send it in the chat as well, and then Mr. Dean can have a look at it.
And the wind tunnel model is nearly done. I'm mostly fiddling around with figuring out how I want to do the control surface mounting.
I know, like, for the tail design, they seem to be working well. Well, at least, like, for horizontal tail, they have a senior and a freshman pair.
Yeah, On and
On and Josiah, and then there's Josha and Isabel.
They seem like
they've
a
been
good
working really well.
team,
They
yeah.
have a lot of good work that they've been producing.
The heaviest weight we held was about 47 pounds, and that was in a point load. So, with one layer. So that was pretty impressive, and that was just a failure that wasn't to breaking, and it bounced back actually very well after that. Like, the only indication that it had even had a load on it was like there's just an indentation from the weight being on there, not even a very large one.
For one thing, please clean up if you're in the shop. And the other thing, I would like you to let me know when you are going into the shop or your members are going into the shop, just so I can kind of manage when people are all going to be there, that type of deal. And so we have some sort of accountability as to who's there when and what's going on. But if you see something that disappeared from the main shop, there's a good chance I moved it back there. I'm still working on like a full training hub. I kind of previewed that Excel sheet to some of you guys. But basically I'm going to create this document where it hosts all the trainings we have, as well as which members have done them, that type of stuff, so we can keep track of the experience level of different members. And again, we have some accountability in terms of who has actually had training, who hasn't, that type of deal.
So, I mean, yeah, this is like option 2. Like, they're still doing like analysis on the 4135. Is that what? 4130. Yeah. And 4140 is the custom motor that we're getting.
Ground mission is working on materials in CAD right now. They're making some good progress. Materials 3 wants to start doing, mission 3 wants to start doing some materials testing soon. So we're gonna buy some silicones, some 3D printer stuff, print up some tests, see how small we can make the adapter before the antenna falls out under weight.
Need control service sizing, but that's like not urgent.
Okay, yeah. Arrow, what do you need from others?
I will say I feel like we can have more of a dialogue with structures than just us giving definite values.
Oh, absolutely. Oh, they love that.
You know how we have our propulsion liaison, basically? We should do the same thing for structures. So, like, since Mace is just working on the fuselage, she'd probably be a good option for that, since she has to interface with so many different teams.
And we basically briefed her on that today already.